Algebra 2, Lesson 108, Sum and Difference of Two Cubes. So this is kind of an expansion or a follow-up on the difference of two squares problems. And then if you'll remember, difference of two squares is this right here. Yep, let's zoom in on it. It's like, hey, instead of writing it down, maybe it's already on the paper. And it was. Okay, so this is difference of two squares here, which is where we have an x squared term and a y squared term, difference being they're subtracted. They're going to factor into x plus y, x minus y, right? And then we can also take that same thing and apply it here because these are all perfectly squared numbers. The x term or the lead term would be 3xy, right? See that? Because that's the square root of this number. The square root of this number would be 2p. Right, so then you have 3xy plus 2p, 3xy minus 2p. That's the difference of two squares theorem. Now we're going to learn about the sum and difference of two cubes. Again, cube referring to the third dimension or an x cubed term. The way the book wrote it down, I really didn't like it, so I wrote it down in this form with x and y. The book starts using first and second terms, and they make it really strange. I don't know why they did it that way. Anyways, this is the sum of two cubes. Again, sum meaning addition. Now, whenever you have two cube numbers being added together, they can be factored into two sets of parentheses. The first set of parentheses is binomial, second set is a trinomial. Cool thing is the binomial set of parentheses will always mimic the cubes, but it won't be cubed. So it'll be the cubed root of these two numbers just being added together. So sign repeats and then the numbers repeat, but the exponents do not. So first half, really simple. X cubed plus y cubed is going to equal x plus y times the FOILed version of this. So it'll be x squared on the first, y squared on the last. The middle term is going to be a subtraction of minus xy. So the sum of two cubes becomes x plus y times x squared minus xy plus y squared. So the only subtraction is the middle term in a sum of cubes, right? So this is the first equation. The second equation is the difference of two cubes, which is the subtraction version. And just like the sum, we can see that we have x cubed, y cubed, and then it factors into single x minus single y. Now the difference between the sum and the difference of two cubes is on the difference of two cubes, the only minus sign is in the lead coefficient. The rest are all positive, right? Let me see. My focus feels like it's slightly... Yep, it was. Sorry about that. Again, first term really simple. X cubed minus y cubed becomes x minus y. And then we have x squared, xy, y squared. And you'll notice the letters in both equations are exactly the same. The only thing that changes is the symbols. So the first plus or minus is going to follow whether or not you're doing sum or difference. The second one will always be the opposite sign. And then the last one will always be positive. All right? So you can think of it same, opposite, positive for the signs. And it's always going to be x plus y, or x, y, x squared, xy, y squared. So that's the equation for difference of two cubes. It seems like a lot to memorize, but it's not too difficult once you start seeing the pattern in the numbers. And then we've done quite a bit of work with quadratics, so this should be a pretty easy form to recognize. Enough talk. Let's talk about how to apply the difference of two cubes. So let's say I've got a number like... Let's do this. Let's say we have 8p to the power of 3, and we'll do a difference minus 27 y to the power of 6. Okay? So what we do here is we just represent this is x cubed, this is y cubed, right? So in order to start writing our term, we just have to figure out what the cubed root of 8p cubed is. So this is going to equal, the cubed root of 8 is 2, the cubed root of p cubed is p, so 2p, and then we're going to have minus, the cubed root of 27 is 3. The cubed root of y to the power of 6 is actually y squared. And that's our first half right there. Now let's work on the second half. All right, now Instead of looking back here, once you have this first number, ignore the problem and start looking at these numbers to fill in your x squared, your y squared, and your xy, right? So then I look at 2p, and what is 2p squared? Well, it's going to be 2 squared, which is 4, p squared, which is p squared. So that's the x squared term. Now I'm going to add xy. So then what is 2p times negative 3y squared? 2 times negative 3 is going to be negative 6, so plus negative 6. Weird, I know. And then p times y squared is just going to be py squared. And then the last one, negative 3y squared. Negative 3 times negative 3 is going to be positive 9. Y squared times y squared is going to be y to the power of 4. And that right there is my answer. So that's how you use difference of two cubes. And then again, if it were an addition problem, I would just use a plus sign, and then I would do the same thing. So these problems aren't too difficult. If you have any questions, let me know on Moodle, and I will see you in class.